first thing that comes to your mind is what? Yes, we are going to look at electric cells. You understand? So whenever you hear electric cell, the first thing that comes to your mind is what? Battery. It's what? Battery. When you use your torch light, you have to put battery, is it not? When you are using your phone, you need battery, is it not? When you are driving your car, you need battery, is it not? So plenty things need battery. So how do you make a battery? Battery is simply the connection or the combination of two or more cells. Two or more cells. You understand? So whenever we are talking about electric battery, electric cells, know that we are talking about what? Batteries. Because when you have more than one cell, you have what? Battery. Exactly. So electric cell is a device used to generate electric what? Force. Needed to move the electrons through internal or external what? Circuits. You understand?
This is so stressful that I don't even know the time.
You need a cell source of charge. So
it was so stressful.
Are source of what? Charge. They produce charges. And when the charges are moving through the circuit, they generate current. They generate what? Current. So it can move through internal or what? External what? Circuit. We have different examples of cells. We have what we call simple or voltaic what? Cell, which is the first one we're going to learn. Simple or voltaic cell. We also have Daniel cell. We have Leclanche cell, and we have what we call accumulators. Is that clear? There are two classes of cells that we have. You understand? You have the primary cell and the secondary cell. The primary cells are those ones that cannot be recharged. You understand? If the car battery, if it runs down, you will take it to a mechanic to recharge it, is it not? Because it is a secondary cell, it is accumulator. But the ones that you cannot recharge, they are known as what? Simple cell or primary cells. Is that clear? So we're going to take these cells one by one. Number one, we'll take voltaic or simple cell. Voltaic or simple cell, they have structures like this. They have structures like what? Like this. They have two electrodes. Two what? Two electrodes. Positive and what? Positive and what? So if this one is the copper, this one will be the what? Zinc. So voltaic cell is made up of positive copper electrode. Positive what? So this one is what? Positive. And negative electrode. Negative zinc what? Electrode. Is that clear? Both of them are dipped inside what? Dilute tetraoxosulfate what? 6 acid. So they are dipped into what? Dilute tetraoxosulfate what? 6 acid. So for you to have a voltaic or simple cell, you need to have two electrodes, copper, which is positive, zinc, which is negative, dipped into what? Dipped into dilute H2SO4. Is that clear? So, yeah, dilute tetraoxosulfate 6 acid. Dilute H2SO4. Or you say, yes, or you say dilute tetraoxosulfate 6 acid. Is that clear? So that is the electrolyte that you put the electrodes inside in order for you to generate what? Current. In order for you to generate what? Charges. Is that clear? So you have electrons will move in this direction. Electrons will move in what direction? This direction. They are moving from the negative. You know electrons are negatively charged. They are moving in this direction. But the conventional direction of current is from what? Positive to what? Negative. So you have the conventional flow of current. Is that clear? You have the conventional flow of current in the reverse what? Direction. In the reverse what? Direction. So whenever you're talking about simple voltaic cell, you're talking about a cell that consists of a positive copper electrode and a what? Negative zinc electrode dipped inside what? Dilute tetraoxosulfate what? 6 acid. Is that clear? Now, there are what we call defects of simple cells. Simple cells, they don't last long. They don't do what? They don't last long. Like the battery car, you see that the battery lasts very long. But simple cells, they don't do what? Last long. They don't do what? Last long. Why don't they last long? Because they have defects. And what are these defects? There are two types of defects of simple cell. We have what we call polarization and local action. We have what we call what? We have polarization and what? Local action. They are the two defects. They are the two things that make simple cells not to do what? Last long. And what is polarization? Polarization is caused due to the formation of what? Hydrogen bubbles on the copper electrode. Can you see this copper electrode? If you start using it, there will be hydrogen bubbles formed around this copper electrode, and that will cause polarization. And how can you correct it? How can you make this thing not to be happening? You can correct polarization by adding the polarizer. You can correct polarization by adding what? The polarizer. And what are the examples of the polarizer that you can add? Copper 2 sulfate solution. Or you can also add iron chloride solution. You can also add what? Iron chloride solution. So another correction for polarization is by doing what? Giving the copper electrode a rough surface. Make sure that the surface of this copper electrode is what? Rough, in order to prevent polarization. So two defects of simple cell are what? Polarization and what? Local action. So what is local action? Local action is caused due to the presence of impurities in the zinc electrode. Can you see the zinc electrode? If this zinc electrode is not pure, it will have impurities. Is that clear? And these impurities are going to create tiny cells, thereby causing the dissolution of zinc. Zinc will be dissolving. Instead of staying static and acting like an electrode, it will be doing what? Dissolving. Once it's dissolving, it will cause what we call what? Local action. Due to the presence of what? Impurities in the what? Zinc electrode, which set up tiny what? Local cells at the zinc surface, causing its what? Dissolution. So how can you check, how can you correct local action? You can correct local action by what? Cleaning the impurities in the zinc with dilute H2SO4. With what? Dilute H2SO4. You clean those impurities. Then after cleaning the impurities, you have to dip the copper into what? Into mercury. You have to dip it into what? Mercury. So that you form what we call what? You have to dip the zinc, not the copper, zinc into mercury, so that you have what we call what? Zinc amalgam. Zinc what? Amalgam. This thing will prevent the formation of what? Local action. So after cleaning the zinc with dilute H2SO4, do what? Dip it into mercury to form zinc amalgam, and that will prevent local action. Is that clear? So that's what we've learned today. Electric cells, like I told you, every battery that you have, whether hello, welcome. Today we are going to be looking at Daniel's cell. Yesterday we started our classes on electric cell. Electric what? Cell. We say that electric cell is similar to our battery. It's similar to our what? Battery. The battery that you use in your phones, in the car, the battery that you use in your torchlight. You understand? They are made up of electric cells. They are made up of what? Electric cells. And we said that we have two classes of cells. We have the primary cells, the ones that run out very easily, and the secondary cells, the ones that stay very long, the ones that you can recharge, like the one you use in your car, in your phones. You can recharge them. They are known as what? Secondary cells. But the ones that you cannot recharge, call them what? Primary cells. I would say that examples of primary cells are simple voltaic cell, which we treated yesterday. Today we are going to look at another primary cell known as Daniel's cell, after which we look at Leclanche cell. All these are what? Primary cells. They cannot be recharged. You understand? Once they are exhausted, they are gone. So example of primary cells are what? Simple voltaic cell, Daniel's cell, and Leclanche cell. So we are moving small to small. We've already done simple voltaic cell. Today, what is Daniel's cell consist of? Daniel's cell is consisting of a negative what? Electrode, zinc electrode. Can you see it? This is the negative zinc electrode. In a porous pot, this is a porous pot. This is a what? Porous pot means that something can enter from outside. Is that clear? In a porous pot containing dilute H2SO4. What is this? Dilute what? H2SO4. Dilute sulfuric acid. Dilute tetraozosulfate 6 acid. Is that clear? This combination now acts in a strong solution of what? Copper 2 sulfate solution. This is a strong solution of what? Copper 2 sulfate solution. Strong solution of what? Copper 2 sulfate solution. And I told us when treating simple cell that copper 2 sulfate acts like a what? Depolarizer. It prevents polarization. So what could be the advantage of this Daniel cell over normal simple cell? It simply means that automatically that the problem of the defect of polarization is already solved. You understand? Because you have one of the components as what? A depolarizer, copper 2 sulfate, which is contained in a copper vessel. Contained in a what? This is a what? Copper vessel. And this copper vessel is acting as the what? Positive electrode. Can you see that? So, you know that on the copper electrode that is positive, there is always polarization happening, which is one of the defects of simple cell. But because of the fact that we are using a copper sulfate, which is a depolarizer, then there will be no polarization effect on Daniel cell. And that's why we have that advantages of Daniel cell. Number one is that polarization does not occur. Polarization does not do what? Occur in Daniel cell. Why? Polarization does not occur at the copper electrode because of the presence of the what? Depolarizer. Because of the presence of the what? Depolarizer, known as what? Copper 2 sulfate solution. Number two, it gives a small current for much longer time than the simple cell. It gives small current for much what? Longer time. Because if there is polarization, small time, the battery will stop working. Is it not? But here, there is a depolarizer, so there is no polarization. So what happens? The battery lasts for a longer time. Is that clear? So if you compare this to the simple cell that we did yesterday, you see that this one has advantage simply because of the what? Copper 2 sulfate depolarizer that prevents polarization. And I told us that there are two defects of a simple cell. Number one is polarization, and number two is what? Local action. Number two is what? Check it in your notes. You understand? But here we are not having the issue. We are not having the issue of polarization because automatically, as one of the components of a Daniel cell, you have a depolarizer known as what? Copper 2 sulfate. Is that clear? So in the next class, we are going to look at Leclanche.
Yes, that was maybe to push. Okay, go back to that.
Yes, let's look at the third primary cell that we have. We said that the three primary cells examples are what? Simple voltaic cell. Number two is what? Daniel cell. And number three is what? Leclanche cell. We want to do the three of them first before we move up to secondary cells. The examples of secondary cells we have are lead acid accumulator. Lead acid what? Or lead nickel accumulator. All these ones, they are cells that can be recharged. Is that clear? The secondary cells can be recharged, but the primary cells cannot be recharged. And the primary cells are simple voltaic cell, we've done it. Daniel cell, we've done it. And today we are doing what? Leclanche cell. Leclanche cell, that's another primary cell. So this Leclanche cell are of two types. They are what? Two types. We have what we call the wet and the what? Dry Leclanche cell. So we are starting with the wet Leclanche cell. Leclanche cell. Wet and what? Dry. So we are starting with the wet one. So this cell consists of a negative zinc rod. Can you see the negative zinc rod? Can you see the zinc rod? It consists of a negative zinc rod dipped in a solution of ammonium chloride. Dipped in a solution of what? Can you see the solution? This is a solution of what? Ammonium chloride. And you can call it what? Sal ammoniac. Sal ammoniac. Sal what? Ammoniac. That's another word for ammonium chloride. And a positive carbon rod and a what? Positive carbon rod. Can you see that it's positive? Positive carbon rod in a mixture of manganese 4 oxide. This carbon rod is inside a mixture of what? powdered carbon and manganese what? 4 oxide. Manganese 4 oxide and what? Carbon. In a what? Porous pot. In a what? This is a porous pot. Understand? So this setup is what we call what? Wet Leclanche what? Cell. What are the advantages of this wet Leclanche cell over dry one, or over Daniel cell, or over simple voltaic cell? What are the disadvantages? Let's go with the disadvantages first. The cell is not suitable for giving current of long what? Duration. It's not good for long duration. You know that when we are doing Daniel cell, we say that Daniel cell has a depolarizer as one of its components, so it stays longer. But this one is not good for what? Long duration life. Because the rate at which the hydrogen is being what? Oxidized. The electrolyte evaporates with time, and such requires occasional addition of what? Water. Because the electrolyte here, it does what? It vaporizes with time. So you need to be adding water to maintain the solution. What are the advantages of this Leclanche cell? The cell is useful in cases where intermittent current of short duration is required. Example is when you are using a ringing ball. Is that clear? Whenever you need light for a very short period of time, you don't need it for a long time. That's when you use wet Leclanche cell, because it doesn't last long. Number 2, the chemicals are easily available and what? Cheap. The chemicals, these chemicals, sal, ammoniac, and manganese 4 oxide, all those things, they are very, very cheap. So you can have this cell or this battery with very little money. Is that clear? That's why you're using it. Not because it's fantastic, but because they are cheap and you can use them for a short period of time cases. Like when you're using ringing balls. Is that clear? So JAMB will ask you which of the following cells is good for ringing balls, and what is the reason? You say it's wet Leclanche cell because of what? The fact that it can give light for a short period of time. Is that clear? Yeah, thank you. Yes, let's finish up with this dry Leclanche cell. So we have two types of what? Leclanche cells, and we have the what? Wet, and we have the what? Dry cells. When you go to buy batteries, sometimes they will ask you what kind of battery do you want? Do you want the one where they use AC, or the one where they use water, and the one where they use AC, or where they get water? You understand? When they say water in acid, what do they mean? Acid. You understand? The one where they wet, where they use water, where they use acid, and the one where they dry. You understand? So you have dry cell and you have what? Wet cell. It's not every battery or every cell that you see liquid, is it? The battery you're using for your phone, does it have liquid? We have wet and dry cells. Exactly. So we've already done wet Leclanche cells. So today we're going to be looking at what? Dry Leclanche cell. And it consists of a what? Zinc pole. It consists of a what? It consists of a zinc pole as the container. See this container? It's a zinc pole. Is that clear? And a paste of a mixture of starch, flour, or ammonium chloride. The paste that will be contained here will be either a mixture of what? Starch, flour, or what? Ammonium chloride. To replace the what? Electrolyte in the case of wet type. In the wet type, you use electrolyte. But here you use a paste. You know what a paste is? Something that is not liquid. But no, your toothpaste, you see the way your toothpaste is. What of your tomato paste? Tomato, the one that they put in tin tomato. It's normally thick, is it not? So you use a paste there. So it replaces the electrolyte in case of a what? Wet type. And a what? Carbon rod as the what? Positive electrode. Can you see the carbon rod? It is the what? Positive electrode. Whereas pole, the zinc pole is the what? Negative what? Electrode. What are the advantages of this kind of battery? Number one, it is portable. It is what? Any battery that does not have liquid is portable, is it not? You can easily carry it, hold it in your hand. You will not be afraid of the acid, may not touch your hand. You know that when acid touches your hand, what will it do? It is corrosive. You understand? But this one now that is having something that does not have acid, you understand? It's easier to carry around. Number two, there is no liquid spill. It does not contain liquid, so nothing will spill. Is it not? Number three, it gives a greater amount of current than the what? Wet type. It gives more current. The wet type gives very small current. What are the disadvantages? There is always slight polarization still occurring because of the slow rate of oxidation of the hydrogen bubbles formed by the what? The polarizer. So there is always a little of polarization that happens here. Is that clear? The other one, you can say there is no polarization, but here there is a little happening. So there is always this fear of small polarization. So this is a dry Leclanche cell. It is what? Portable. It is what? Portable. You can easily move it around. And there is no liquid spill as you're carrying it around. So that's the two advantages that it has over the wet type. Is that clear? So thank you. Yes, we are going to be looking at primary and secondary cells. We are going to be looking at what? Primary cells and secondary cells. In the last class, we learned about the primary cells. What are the examples of primary cells? Simple voltaic cell, Daniel cell, and Leclanche cell. Three of them are what? Primary cells. Why are they primary cells? Because they are cells that cannot be what? Recharged once they are used up. Once you use up a primary cell, you cannot recharge them. You understand? So examples are what? Simple voltaic cell, Daniel, and what? Leclanche cells. Those are the examples of what? Primary cells. Now we have another type of cell known as secondary or storage cells. You can also call them accumulators. You can also call them what? Yeah, because they can be recharged and they can be used for a very long time. You understand? The major defect of a simple cell known as polarization does not occur in secondary cells. Is that clear? That's why they can run for a long time. And when they are used up, you can do what? Recharge them. A good examples of those, there are two examples. We call them what? Lead acid accumulator and what? Nickel-cadmium or nickel-iron what? Alkaline cell. Is that clear? So these two are examples of what? Secondary cells. And secondary cells are cells that can be what? Recharged when they are used up. They last for a long time without polarization. They can be effectively used in motor vehicles. They can be effectively used in where? Motor vehicles. That's the kind of batteries that you use in motor. They call them accumulators. You understand? Lead acid accumulator or nickel-cadmium or nickel-iron alkaline cell. What are the disadvantages of this accumulator, this storage cell? What are the advantages? They are too heavy. They are too what? Heavy. Have you carried the battery of a car before? It's very heavy when you carry them. You understand? Unlike the other simple cells that you can hold in your hand. They are very heavy. That battery that you use for torchlight, when it discharges, can you recharge it? You throw them away. You cannot recharge it because they are simple cells. You understand? But these ones, when they discharge, you can recharge them. They can be damaged if carelessly charged. When you're charging them, you have to charge them very carefully. That the plates are attacked by acid electrolyte if left without being used. You understand? Some battery, when you go to buy them, that's when they will pour the acid. You understand? Because if you leave the acid there for a long time, it will spoil the battery. So take note, primary and secondary cells. Primary cells are the ones that they cannot be recharged when they are used up. Secondary, you can recharge them when they are used up, and they can be used for longer time. They are the batteries that you use for cars and other places. You understand? So take note of these two types of cells. Thank you. So in subsequent classes, we are going to be learning about lead acid accumulator and nickel-cadmium or nickel-iron alkaline cells. Yes, today we are going to be looking at lead acid accumulator. The kind of cell that you use in motor battery in your cars. Is that clear? the cars that you see driving on the streets and roads, they use the kind of cell or battery known as what? Lead acid what? Accumulator. So whenever you hear lead acid accumulator, your mind should go to car battery. Your mind should go to what? Car battery. So what is the arrangement inside that car battery that you carry? This consists of red lead. You can see back. Lead 304. You understand? This is the formula for the red lead. As positive what? Electrode. You know that every cell must have a positive and what? Negative electrode. So the positive is red lead, whereas the negative electrode is what? Lead oxide, BbO. You understand? So red lead, Bb304 is what? Positive electrode, whereas lead oxide, BbO, is the what? Negative electrode. On charging, the positive electrode, which one is the positive electrode? Red lead, but it becomes, on charging now, the positive electrode will change. It will no longer be this. It will become what? Red oxide. Instead of being negative, it will turn to positive. You understand? Why the negative electrode will now be converted to what? Lead. So the electrode changes. You understand? This one will, when it's discharging, when you're using it, you understand? The positive electrode will be red lead, and the negative will be what? Lead oxide. When you're using it, but after using it, when the battery is low, when you want to charge it, the two electrode changes. You understand? It becomes negative. You understand? So and it reverses. That's why you can recharge it. You understand? If not, once you finish using it, it will not be used again. But because you can reverse the electrode during charging and during discharging, that's why you can recharge. The electrolyte is dilute what? Tetraoxosulfate what? 6 acid. On discharging, lead 2 sulfate forms slowly on the plate, while the acid becomes more dilute. You understand? You see that the acid is what? Dilute tetraoxosulfate 6. When you keep using it, it will become more dilute. So it will now have a density of what? 1.15. But the one that is fresh, that is not yet used, the density is what? 1.25. You understand? So when it is discharged, it will have density of what? You see that? This is the EMF, the potential difference. You understand? The EMF, the power of the acid to drive current. We've learned what EMF is. Right? This is the power of the what? Acid. You understand? So a normal acid that is well charged has the EMF of what? 2.2 volts. So JAMB is going to ask you, which of the following are the parameter values for a fully charged battery? They will give you EMF 2.2, relative density 1.15, 1.25. Which one is the answer? The relative density of a fully charged battery has to be what? 1.25, and the EMF has to be what? 2.2 volts. Is that clear? So when you continue using your battery, when it's discharging, the acid, the electrolyte will become more dilute. That's why they say if you want to go and recharge your battery, when you take it to mechanic, they say let's change the acid, because they want to put an acid that has the right relative density of what? 1.25, so that it can be working normally. Exactly. So lead acid accumulator, very, very important. It is the kind of battery that we use in cars. Exactly. Yes, today we are going to be looking at nickel-cadmium alkaline cell. Nickel what? Cadmium alkaline cell. The first one we learned about lead acid accumulator. You know we have acid, we have base, we have what? Salt. Is it not? Acid, base, salt in chemistry. Is it not? Acid that has pH of 1 to 7. Base that has pH of 7 to what? 40. Understand? Neutral is around 7 bar. Good. So if you want to prepare a battery, it's either you're having lead acid or you have lead alkaline. You understand? Alkaline is another word for base. Alkaline is another word for what? So we learned about lead acid the first time. Now we are looking at lead. We are looking at nickel-alkaline. I mean, not nickel, lead alkaline. Actually, nickel-alkaline. Is that clear? That's another kind of accumulator that you have. You understand? I told us that we have 2 types of accumulator. two types of secondary cell, two types of storage cell. So you can either call it accumulator, secondary cell, or what? Storage cell. Two types. And number one is what? Lead acid accumulator, which is what we just finished learning. Now we're going to be learning about nickel cadmium alkaline cell. So the first one is acidic in nature. Acidic in nature. This one is what? Basic or alkaline in nature. And this consists of a positive electrode of what? Nickel plated what? Iron tubes. Those iron tubes are packed or filled with what? Nickel 2 hydroxide. And a negative electrode of what? Similar to, but this time around filled with what? Cadmium. And a little iron to improve on its what? Efficiency. Now, a nickel plated steel is used as the what? Container. And potassium hydroxide solution as the what? Electrolyte. You can see that the electrolyte is what? Potassium hydroxide, which is a base or an alkaline. But in the lead acid accumulator that we learned earlier, the electrolyte is what? Tetrahydrosulfate, what? 6 acid. You see the difference? So in the electrolyte here is a base, the other one is alkaline. The other one is acidic. What are the advantages of alkaline cell? They can be what? Recharged. They can charge at a high rate without what? Damage. They have longer lifespan than the what? Lead acid accumulator. They can be left for a long time in discharge stage without what? Damage. The electrolyte requires no attention, unlike the other one that you have to be very careful. They are lighter than what? The lead acid accumulator. If you carry them, they are lighter. The other one, they are very heavy. The lead acid accumulators are very heavy. What are the disadvantages of alkaline cell? Number one, the cell has low what? EMF. And you know that EMF simply is the power of the cell to carry things. Any cell that has smaller EMF might not carry bigger things. So you see, the other one will carry bigger, lead acid accumulators will carry bigger cars, whereas these ones are likely to carry smaller ones because their EMF is the normal EMF of a fully charged battery, which is 1.25. And this EMF continues to what? Fall down as the battery is being what? Discharged. Thank you. Yes, welcome. Please, today we are going to look at arrangements of cells. We are going to look at what? We said that to form a battery, you need two or more what? Cells connected together. To form a battery, you need two or more cells connected together. So how do you know how to arrange your battery? Are you going to connect them in series or in parallel? You understand? So as to form a battery. Is it not? You use cells to form a what? Battery. When you have more than one cell, you call it what? Battery. You understand? So here we say battery is formed when two or more cells are connected together. There are two ways cells are connected. Number one is parallel, number two is what? Series. We did this when we are learning resistor arrangement. Resistor and cell arrangement are the same thing. You understand? Although you find out that capacitor is different. We'll learn about capacitor later, you understand? But know that for parallel connection, this is what we have, you understand? One over the other. This cell 1 with EMF 1 back. You know that EMF is the power of the cell to push out charges, is it not? So this is the EMF of this one, this is the EMF of that one. Then they are telling us that the effective EMF, which is the combined EMF, is the same as the EMS of each of any of them. Is that clear? Or if you want to calculate their total internal resistance, the same way that you calculate resistance for resistors that are in parallel, which is what? The reciprocal of the effective is equal to 1 over R1 all over 1 over R2 all over 1 over R1. This is their internal what? Resistance. Internal what? Now, series connection is when you have an arrangement like this. Yeah? One connected directly to the other and the other one to the other. Call it what? Series connection. The combined EMF is simply the just what? The addition of the individual what? EMFs. You understand? So the effective E is equal to what? E1 plus E2 plus what? E3. And the total internal resistance is the same thing for resistance in series. R is equal to what? R1 plus R2 plus what? R3. These two arrangements, this one is better. The series connection is what? Better. because it ensures that the battery stays longer. You understand? Unlike this one that when you leave it, it will exhaust quickly. This one stays longer because of the nature of the what? Connection. So have it in your mind. There are two arrangements for cells in a battery. It's either that the arrangement is parallel or what? Series. You understand? And how you calculate the effective EMF or resistance depends on the what? Arrangement. If it is parallel, you use the reciprocal of the effective resistance is equal to what? 1 over the reciprocal of resistance 1 plus the reciprocal of resistance 2 plus the reciprocal of resistance what? 3. Whereas their effective EMF is the same as the individual what? EMFs. Is that clear? Please get that in mind, because we are going to be solving calculation now. Thank you. Good. You're going to be looking at cell calculations of cells, you understand? Whenever you're looking at cell, who can tell me the two major parameters that you calculate for a cell? EMF and what? Internal resistance. What? EMF and what? Internal resistance. Those are the things that concern the cell alone. EMF is the what? The force which pushes out what? Charges that will cause current due to its flow. You understand? Internal resistance is the ability to prevent the free flow of that charges inside the cell. Inside the cell, that's why you call it internal. There are also resistors that are connected on the circuit, but you are not looking at the resistance of those resistors. You are looking at the resistance of the materials of the cell. So two parameters that you normally check is what? EMF, electromotive force, which is the potential difference that causes the flow of what? Charges. The energy that causes the flow of what? Charges. That is EMF. Then what? Internal what? Resistance. Two things. So we are going to look at an example. Example 1. The cells of EMF. 3. Please, this is 3. This is what? This is what? 3, please. 3 cells. You understand? 3 cells. We are looking at how many cells? 3 cells. It's not 1. It's not 2. 3. Of EMF what? 3 volts. All of them are of EMF what? And internal resistance what? 0.3. 0.5 ohms. Are connected in what? Parallel. They are connected in what? So how do I do it? Like this, ba? Is it like this? Am I doing it well? Am I doing it well?
Yes, sir.
This is what? Parallel connection. This is what? EMF 1 bar. EMF what? 2. EMF what? 3. And this is internal resistance what? 1. Internal resistance what? Internal resistance what? 3. So they are telling you that all the internal resistance are what? 0.5 ohms. This one is also what? This one is also what? Whereas their EMFs are what? 3 watts, 3 volts. This one is also what? This one is also what? So they have equal magnitudes of the parameters. You understand? Connected in what? Parallel. This is parallel connection, is it not? In order to reduce the total potential what? Difference across the circuit. Determine the effective what? Internal what? Resistance. But determine the effective what? Internal resistance. So because this thing is in parallel, what formula are we going to use? 1 over what? Effective resistance equal to 1 over R1 plus 1 over R2 plus 1 over what? R3. So R1 is what? 0.5, 0.5, 0.5 for R2 and 3. But so you get the LCM. What's the LCM? How did we get 6? This is how you do this. LCM of 0.5, 0.5 is also 0.5. 0.5 divided by 0.5, 1. 1 times 1, 1 plus 0.5 divided by 0.5, 1. 1 times 1, 1. 0.5 divided by 0.5, 1. 1 times 1, 1. So we have what? 3 over what? 0.5. And 3 over 0.5 is what? 6. That's why you got 6 here. But because this is 1 over F, you need to take the reciprocal. So RF will now be equal to what? 1 over what? 6 ohms. That is the answer. So how we got 6 ohms here is by doing what? Finding the LCM of this, which is 0.5. When you solve out, you have 3 over 0.5. If you use your calculator and press 3 over 0.5, you get what? 6. You understand? So 1 over ROF is equal to what? 6. So what is ROF alone? You take this one over here. 1 over what? 6 ohms. Is that clear? That's how we solved it. So please take note. The formula that you use will depend on the what? Arrangement of the what? Cell. Whether it's parallel or what? Series. Had it been in series, what would have been the total R?
R1 plus R2 plus R3.
For series, the E efficiency would have been what? R1 plus what? Plus what? R3, which would have given us what? 0.5 plus 0.5 plus what? 0.5, which will give us what? 1.5 ohms. Is that clear? Is that clear? Thank you.